Welcome to AWS Tutorials. My name is Kastro Kiran. In the last video, we have seen how to work with S3 object lock concept. In this video, we are going to talk about one of the important concepts that is available in S3 service, which is known as S3 security. Along with S3 security concept, we'll also be talking about another sub-concept in order to understand security concept, which is known as encryption. And we'll also be talking about the different types of encryptions that we have. Now, to understand S3 security concept, let's look at a scenario here. We know that in AWS cloud, we have multiple regions. And in each region, different AWS accounts will be creating multiple resources, such as creating an S3 bucket, uploading an object into S3 buckets, creating an EC2 instances, creating an RDS instances. Like this, different AWS accounts will be doing different activities in each of the regions that are available in AWS cloud. Now, let's say in one of the regions, multiple AWS accounts have created their S3 buckets and uploaded the objects into each S3 bucket. Assume that all these buckets belongs to different AWS accounts. Now here, there is a question that what will happen if someone hacks the AWS cloud or a specific region in the AWS cloud, and if they access the data that is available in the S3 bucket, there is a chance that the data transfer can happen. Why? Because hackers might hack a specific region that is available in the AWS cloud, and they might hack the data, whatever is available in the S3 buckets or the data that is available in a specific region. Now, to take care of this, AWS has brought a concept which is known as S3 security. So far, we have studied two types of S3 security methods. The first one is known as block all public access, and the second one is known as ACLs, that is access control list. So we have already talked about how to secure the objects that are available in an S3 bucket by enabling block all public access and by also enabling ACLs, that is access control list. But apart from these two methods, we also have multiple methods of providing additional layer of security to the objects and also to the buckets that are available in the S3 service. Before talking about the different methods that are available to provide additional layer of security to the objects or to the buckets, let us understand a simple concept which is known as encryption. Now, let us understand what is meant by encryption. Now, here you can see there is some data that is available on the screen, which is easily readable by any human who knows basic English. Suppose, let's say, here the statement is read as how to easily add icons to Windows folders. So this data I'm able to read. Now, what I am going to do by using encryption concept is I am going to convert this data into alphanumeric characters, which is not understandable by humans and which is also not understandable by the machine also. Machine in the sense the computers or the software. This is called as encryption. So encryption is nothing but conversion of human understandable language into non-understandable language, either by machines or by humans, is known as encryption. Now, to do this encryption, anytime we need one key, and that key is known as encryption key. Without encryption key, it is not possible to encrypt a data or to decrypt a data. So to keep it simple, to encrypt an object or a bucket that is available in the S3 service, we need to have an encryption key. Now, what is this encryption key? Encryption key is something which contains alphanumeric characters. And these alphanumeric characters cannot be decoded until or unless you have the encryption key. So here, encryption key plays an important role to encrypt the data or to decrypt the data. Now here, AWS provides the facility of generating this encryption key when we choose or when we ask AWS to create the encryption key for a bucket or to an object. So that is about encryption. To keep it simple, encryption is nothing but conversion of human understandable language to non-understandable language in the form of alphanumeric characters is known as encryption. To do encryption, it is important to have the encryption key, and this encryption key will contain the alphanumeric characters. Now, let us see what are the different types of encryptions that we have. In general, we have two types of encryptions. The first one is called as encryption at rest, and the second one is known as encryption in transit. These are the two general types of encryptions that we have. Now, let us understand what is meant by encryption at rest and what is meant by encryption in transit. Now, let us understand a scenario of encryption at rest. Let's say you have a laptop, and in this laptop, you have some files that are available. Now, these files, you want to transfer it to some other person. Now, in order to transfer the files to some other person, let's say that you are using pen drive as an external medium, and in this pen drive, whatever the files that are available in the laptop, you are going to copy those files into the pen drive. Now, here there is a problem. The problem is there is always a chance that the pen drives or the external hard disk might get thefted away or might get stolen away by unknown persons. Now, in that case, whatever data that you have kept inside the pen drive, that data is lost, and that data is readable or understandable to the person whoever has thefted this data. Now, here comes the actual problem. What is the actual problem? The actual problem is you're keeping the most important data into the pen drive, and that data is something which is understandable by any humans. Suppose, let's say you have kept some files into the pen drive, and these files, when the person opens, they can easily read what is the data that is available in the pen drive. So in this case, what you can do is you can use a concept called encryption. So what you will do is whatever data that is available in your laptop, that data you are going to encrypt that into non-understandable language, where the data gets converted into alphanumeric characters. Now, in that case, what will happen is even if the pen drive is lost, and even if the files are being accessible to the third party person, when they try to open the files, they will not be able to understand the data, whatever is available in the objects or in the files. Why? Because we have encrypted the data. That means we have converted the human understandable language into a non-understandable language in the form of alphanumeric characters. Now, in order to decrypt the data, suppose, let's say, I was telling whenever you want to encrypt the data, you need to have an encryption key to decrypt the same data. Now, the person who had stolen the pen drive, he might have the pen drive and he might have the files to access. But when the person tries to open the file, he will not be able to read the data that is available in the file. Why? Because the data is encrypted. So here, in order to decrypt the data, he needs an encryption key. So to keep it simple, encryption at rest is nothing but it involves encrypting the data while it is stored on a physical device such as hard disks or SSD drives or pen drives or memory cards, whatever it is. So that's called as encryption at rest. So encryption at rest is nothing but when you are storing the data into any external devices, you will store the data in the form of encrypted data. Now, as I was mentioning earlier, in order to encrypt the data or to decrypt the data, we need an encryption key. Without this encryption key, it is not possible to encrypt the data, or it is also not possible to decrypt the data. So in this case, even if the pen drive is lost, the person should have the encrypted key in order to access the data or in order to read the data that is available in the pen drive. So this particular encryption key helps to protect the data from unauthorized access, even if the device is stolen or lost. This is called as encryption at rest. And the second type of encryption is known as encryption in transit. Let us understand the encryption in transit with a simple scenario. The scenario is, let's say that you want to do some banking transaction using the mobile application. Now we know that for any application or for any website, there will be servers that will be working in the backend. Now, whenever you want to do the money transactions using the mobile application, first the server will ask you to enter the username and password. Once you enter the username and password, the servers will provide you the access to do the banking transaction. Now, let's say whatever the application or whatever the website that you are using, it is not highly secure. Now, whenever you are trying to enter the username and password, and if the mobile application is not a secured application, or if the website is not a secured application, there is a chance that this username and password will be accessed by the hackers. Now, when the hackers access these username and password, they can do the transaction on their own and you will be on the losing side. Now, in this case, what should happen is whatever the websites or the applications that you are using, they should be having high level of security because they are consisting of some sensitive information which are related to banking application. Now, in general, if you take any website, there are two types of websites that we have. One website is known as HTTP website, and the other website is known as HTTPS website. In general, HTTP website is something which is not so secure, and HTTPS websites are something which are highly secure. Now here, encryption in transit is nothing but when you are entering the data, okay, when you are entering the data in the mobile application or in the web application, there is a chance that if the website or application is not highly secured, and in this case, whatever data, that is username and password, that you are entering to access the mobile application, this data can be accessed by the third party persons whom we can call it as hackers. And when hackers can get this data, they can hack your bank account and they can do the money transactions without your knowledge. And this is called as encryption in transit. So it basically refers to the practice of safeguarding the data while it is transferred between two different points. So here, the 2 points are the mobile application and the servers. So when you are transferring the data or when you are entering the data in your mobile application, it will go and connect to the servers. The username and password will go and connect to the servers. So in this case, the hackers can access this data. So to safeguard your data, what we do is we are going to use encryption in transit. So these are the two types of encryptions that we have. One is called as encryption at rest, and the second one is known as encryption in transit. Encryption at rest mostly focuses on the data that is already available in the devices, whereas encryption in transit focuses on when the data is transferred between two endpoints. In between, if someone can access the data, that provides no layer of security to the data. So to keep these factors in mind, we need to work with encryption concept in the S3 service. Now let's look at what are the different security methods that we have in the S3 security. So there are basically two types of security methods that we have in order to secure an object or a bucket in the S3 service. The first type of security method is known as encryption at rest, and the second type of security method is known as access permissions. Here in encryption at rest, again it is divided into four categories, but broadly encryption at rest has divided into two categories. The first one is called as server side encryption, and the second one is known as client side encryption or customer side encryption. Again, in server side encryption, we have one category which is known as SSE-S3. And the second type of encryption at rest is known as server side encryption, which is basically talking about KMS, that's called as key management service. And the third category is known as server side encryption, which is relevant to customer managed key, that is also called as CMK. So these are the four types of encryptions that we have under the category of encryption at rest. And the second way of securing the objects or buckets is by using access permissions. In access permissions, again, it got divided into three categories. The first category is known as bucket policy, where we write the bucket policy in the JSON format. And the second way of securing the objects using access permissions is by using access control list, which is called as ACL. Now, again in ACL, we have two categories. One is ACL, which will work at a bucket level, and the second one is ACL, which will work at object level. We have already talked about how to work with the ACL concept in our previous videos. The third way of securing the object is by using pre-signed URLs. So these are the different methods of securing an object or a bucket by using security concept. Let us understand each one of these concepts individually. First one is encryption at rest, which is SSE S3. By default, whenever you are creating a bucket, you will have SSE S3 as the default encryption key. And this SSE S3 key is provided by AWS itself, and we don't have any kind of permissions to create the key or to delete the key, or we cannot do any kind of activity with the key that is created by AWS. And this key is completely managed by the AWS itself, and hence we call that as SSE S3, which is by default enabled whenever we are creating an S3 bucket. And here we don't have any kinds of permissions to manage this key. Everything will be taken care by the S3 service itself or the AWS cloud itself. And the second type of encryption at rest is known as KMS, which is also called as key management service. Now, this KMS is something which will be created by AWS. And by using this KMS key, we can manage the key. That is, we can create a new key if we want, and we can also delete the KMS key whenever we don't need that key. But here, we will have the complete permissions to manage the KMS key. And KMS key is a region-specific service, and also it supports multi-region as well. That means whenever you are creating a KMS key, you can create the same KMS key in multiple regions. And this KMS key is also having an additional feature which will support the key rotation for every 365 days. Suppose, what does it mean by key rotation is, every 365 days, the key will get continuously updated, so that even if the third-party persons access this key, since there is a key rotation for every 365 days, they cannot be using this key more than 365 days. That's the advantage of working with KMS. And the third category is CMK, which is known as customer managed key. Now, customer managed key is something which will be managed by the customer itself. That means here the client or the AWS user has to create this key, and they has to maintain everything related to the key permissions. That means creating the key, deleting the key, giving the access permissions, everything has to be managed by the client itself or the AWS user itself. Since complete permissions are available with the users, AWS will charge for this kind of key, which is a CMK key. And the fourth category is known as customer side encryption or client side encryption. As the name itself tells that here customer has to encrypt the key, customer has to decrypt the key. That means whatever data that you are going to upload into the S3 bucket, if you upload the encrypted data, AWS will store only encrypted data. If you upload decrypted data, AWS will store only the decrypted data. So here, when you are choosing CSE in the S3 security, everything has to be taken care by the client itself. AWS will not have, or AWS will not take care of encryption part, and AWS will also not take care of decryption part as well. And let's talk about the second way of securing the objects or buckets, which is by using the access permissions. We know that by default, whenever you upload an object into the S3 bucket, they all will be in the private mode itself. So there are additional layer of securities in the access permissions. The first one is known as bucket policy, which will work at bucket level. So here, bucket policy is something where we are going to write in a format that is known as JSON format. When we are working with the practical concept of S3 security, I'll be focusing on mostly on bucket policy, that is how to create a bucket policy, how to write the bucket policy, and how to attach that bucket policy to the bucket. For time being, let us understand that bucket policy is something which will work at bucket level, and this is written in the form of JSON format. And the second layer of security in access permissions is known as ACL, that is access control list. Now here, ACL can work in two different layers. One is at bucket level and the second one is at object level. We have already talked about how to enable the ACL, how to disable the ACL, what are the advantages of enabling the ACL, and what are the advantages of disabling the ACL. All these things we have talked in the previous videos. If you want, you can refer to the previous videos. And the third layer of security in access permissions is known as pre-signed URLs. Basically, these pre-signed URLs will work at object level. Now, what is meant by pre-signed URL is, suppose let's say you want to give the permission to access the object to the third party person for a specific period of time. So when you want to give the access for a specific object only for a limited duration, in that case, we are going to use this concept called pre-signed URLs, which will work only at object level, not at the bucket level. Now let us look at how the encryption options are available in the AWS console, especially in the S3 service. As I was telling, by default, whenever you are creating an S3 bucket, SSE S3 will be enabled. If you want to explicitly enable the KMS or DSSE, that is dual layer server side encryption KMS, you have to explicitly enable this option. And here, remember, as I was mentioning earlier, dual layer server side encryption is something which is charged. When you are creating the DSSE KMS key, you have to pay for AWS because AWS is going to provide you additional layer of features when you are creating DSSE KMS. But mostly when we are working with the real-time scenarios, we'll be working with KMS key. In the demos that we are going to see in the upcoming videos, I'll be focusing mostly on how to create a KMS key and how to use that KMS key to encrypt and decrypt the data. So this is how the encryption option is available in the S3 console. And this is the latest view. If you see the oldest view of the S3 console, especially with the encryption part, earlier it used to ask, AWS used to ask whether we need to enable the encryption or disable the encryption. If you want to enable the encryption, we have to explicitly enable the encryption. By default, in the old console, the encryption was disabled. But in the latest console, by default, the encryption will be enabled with an option of SSE S3. And once you enable the encryption, you can select the SSE S3 or SSE KMS. So based upon your requirement, if you select SSE S3, you have to create, or AWS will create the SSE S3 keys. But if you select KMS key, you have to enable the server side encryption. And once you enable the server side encryption, you need to, if you want to create the KMS key, you have to create the KMS key. So this is how the old console and new console looks like when we need to enable the encryption for a bucket or for an object by using different encryption options. In the next video, we are going to see the practical concept on the S3 security concept. Thank you. We'll meet in the next video.